A question is, what is echo? Echo could be a part of the actual bash shell, or it could be its own standalone program. And a lot of things like grep are standalone programs. We'll discuss what grep is in a little bit. But they're no different than Photoshop, or I go on my Macintosh and open up some other program that I'm going to use. Like at the moment I'm recording in this very nice video editing tool. But it's its own standalone program, which means that the bash shell is extensible by you adding programs. And we're actually going to add simple little programs to bash during this process. So how about just finding out what the current date is? Let's do that. If we do date, we find out the current date. And if we do the manual for date, we'll find out that it has a whole slew of different options that we can do. And if you hit a space in the manual pages, it's going to walk you through different pages full of options and how you can actually format a date so that you can get it output in the format that you want. And it even gives you some examples. Like, good heavens, what is that example right there? Let's do that, and then let's paste in this date example and do that compared to that date example. Well, that looks like, to me, it is very, very similar. But you see that there's lots of options on date, and you can go read what the options are. How about something a little bit more complicated than a date? How about a calendar? I find that to be a very useful thing. Not only does it tell me the date, but it gives me a little calendar for the month. You can also find out a calendar for the entire year. In this case, I'm giving it an option that says, for the year 2020, what is the calendar? And there is a calendar for the entire year, which, here's today's date, tax day, and here is the entire year that we're looking at. And up here someplace, right about there, is the end of the semester. So, kind of cool that I can get a calendar. One of those things, it's going to be an exercise, is try 1752. Something happens in 1752. If I type calendar instead of cat, there we go. Take a look at September of 1752. Something odd happens right at about the 3rd of September, 1752. You'll have to do some history books to find out why 1752 is different, but there's definitely the shortest month of the year. The shortest month of a lot of years. So we can look at something like calendar and we can provide it different options in different ways. Often options are preceded with a minus sign. And these are flags that get sent to the program. Usually the single minus sign means that it's a single letter flag, which is an abbreviation for a longer flag that has 2 minus signs. And we can try out different things. Let's try, when we want to list a file to the screen, I have a file in here called abc.txt. Right there, and I want to see what's in it. I can do cat abc.txt. Why is it called cat? Because it's actually the concatenate program. There are reasons why, but I see that it's got 3 ABCs in it. If I want it with line numbers, I can do cat minus n. And that option with the minus n says number everything, and I get line numbers. I can do it more than once. And I get 2 copies of the file. So I've actually, in a certain sense, concatenated 2 different files together. So we can build things that have line numbers. We can see stuff as output. We've got a little bit of a handle on what some options are. But we like to see what we mean by it's an abbreviation for options. There's a grep command that has much more complex options than cat. If I do man grep, Oh my goodness. Look at all of the single letter options that it has. And then it gets into longer options like context, and somewhere in here there is an exclude option. But if we go down and we look at exclude, you'll see the 2 minus signs and a full word for an option. So we can actually exclude things from whatever grep does. But if you look at the man page, you hit a space to go to the next screenful, or you hit a Q to exit in the middle, and the man pages are available. On Windows, generally speaking, it doesn't have the man pages, but you can get those same man pages by going into Google and doing grep, or Googling for man grep, and you'll see the same kind of man pages. They're online. So there's a way to get the man pages. Now, where do all these commands come from? I mean, if they're extensible, how does the shell find them? Now, the shell actually has variables. I can say A equals 12, and I can echo A and get back 12. But it also has some special variables. These are the exported that it uses for various different things. And one of those variables is the path. That's my path at the command line. Different programs can have different paths set in the Unix world. In the Windows world, the path is set system-wide and you only get one of them. Whenever I go into Windows and I go to set the path, I've got to do a lot of work to go find out how to set it. But if you're using the bash shell, it's per shell. If I go into the editor, I can actually ask what is the path inside the editor. And I have a much smaller path when I'm inside the editor. That's the one we're going to take a look at. But the path basically is this list of directories that is separated that says go search in all of these directories for the commands you want to run. And my particular path inside the editor starts with dot and is separated with colon, and then it's got some particular piece of the path right here that is the next place where it searches for stuff. And there's a bunch of them. You'll notice that my path at the command line has all sorts of things and is quite long. My command line path is actually separated with semicolons in some cases. But either way, the path says go look in these directories for what you're going to be working with. So when I do cat ABC text, it actually goes out to the path and it goes searching for this. There's a tool called which that'll tell me where I find cat, and I happen to find it in bin cat. Now, there's nothing magical about these, and you can have overlaps in names, but let's say that you really want to search in your current directory for a cat and you want to implement your own version of cat. So I'll build a tiny little program that says cat, and for this particular cat, all it's going to do is bark. Because I just think, naming your dog Meow and having your cat bark is cute. So I'm going to compile this. And now when I do cat, it's actually going to say bark instead of copying out a file. The reason that that happens is because if you looked at the path, the first thing in my path is a dot. The dot refers to the current directory. If I do ... it refers to the parent of the current directory. But I'm saying that whenever you look for commands, the first place to look for that command is in the current directory. So I created a cat in the current directory. In fact, let's do it this way. ls-l says give me a long listing of the files, and I happen to now have a cat in the current directory. The place where you start to see the importance of the path is, let's say you install a copy of Python on your system. and you're expecting to get the most recent version, which I think is version 3.8.4. And you go and run Python because you needed the current version, and you go, why is my program broken? And then you dig a little bit deeper and you run Python and find out, by golly, the Python that I'm executing is version 2.7. But I just installed 3.8.4, didn't I? A little bit of checking and you go, yeah, I did. What happened to it? Well, what happened is Python 2.7 is found first in your path, and that's what your shell or your system or your explorer, whatever tool you are using for a shell, that's what it's executing, instead of executing the one that you want. And the thing you've got to go change is the ordering in your path. Sometimes this really mucks things up, but at least in the land of a Unix shell, it's easier to unmuck because each shell has its own different path. Windows just has one path unless you're running something like Bash, and then the path is actually dependent again on the shell. So this is what we have in the path, is the order that it searches for things. And what's in this directory / user bin, I think it was, or bin? There's a bunch of different commands like date and ed and ksh. All these different commands are up there in the shell and available for you to use. Let's start with a specific command and take a look at that command in a little bit more detail. I'm going to work on a command move first, but if you break down the path that you see, I've got the current directory, I've got my home directory, user pshlump, and a bin directory. I put stuff in my own bin directory, not just in the system bin directory. So I've got all these other commands that I've added to my own system that I use in my system, shortcuts, tools that I use, things that I have built for myself, a whole bunch of them to make my life better. And that's what's in my bin directory. I've got Go programs that also have their own bin directory. A couple of different directories with those, both in mine and user local, which is system-wide. User bin, which is more commands. Bin, which I showed you, has a few things in it. All of these different things. In fact, I'm on a Windows system, and I also have a different Windows system than the default system windowing tool. I have X11 as well. So all of these things. And this is just my little short path that I have inside my editor, as opposed to my full path that has even more things in it. But this is where it looks sequentially for commands. And every time I run something, or I open something, or I double-click and run an application, it's using this kind of a path to go search for things. When it fails to find something, like let's say that it says command not found, what that means is that it went and searched the path and there was no file XXYYZZ that was executable that it could run.